Good morning, and today we are going to finish this unit. So we're going to do section 3.5, and this is limits at infinity. So basically we're going to take limits as x approaches plus or minus infinity, and we're going to deal with infinite outputs with limits. And we've done some of this, but today we're just going to take it a little bit further, and a lot of it will be review. Okay, so let's review our definition of a horizontal asymptote. So for a horizontal asymptote, if we kind of just remember, if I have some function and maybe this right here, y equals 2, was a horizontal asymptote. Remember, you can cross a horizontal asymptote. It's in the long run that you are approaching it. So the limit as you go to infinity, you may be approaching y equals 2. So if you take the limit to infinity and you get out 2, then we know y equals 2 is a horizontal asymptote. Similarly, let's say that I had kind of that same function going on. And let's say when I went to negative infinity, it approached negative 2. So I don't have to approach the same asymptote, but again, it's in the long run. So if this is a negative 2, then y equals negative 2 is another horizontal asymptote. So you may have more than one horizontal asymptote. Okay, so when we are dealing here with some rational expressions or even just a function over a function as I'm going to infinity, then we have basically three different scenarios that can happen. We can have the degree of the numerator is bigger, and so basically there are no horizontal asymptotes, because it'd be like going to infinity or negative infinity. Oops, hold on. I don't think that said plus or minus up here. We should have plus or minus infinity. Okay? Sorry about that. 2, if the degree of the denominator is greater, then y equals 0 is a horizontal asymptote. And then 3, if the degrees are equal, then we're going to be looking at the leading coefficient over the leading coefficient. Now this one gets tricky when we're dealing with the limit as x approaches negative infinity. And we're going to see that in some of these examples. Now, if I just have a rational expression here, then you're going to have the same asymptote as you go to plus or minus infinity. But if you don't have a rational expression, and remember a rational expression is a polynomial divided by a polynomial, so if I have maybe something with a radical or fractional exponents, then we could get two different answers as I go to plus and minus infinity. So I could have two horizontal asymptotes. Okay, verse 1. But we should always just be checking to see that. So here, let's say that this is my polynomial over a polynomial, so it is a rational expression. So I know that as I go to plus or minus infinity, I should get the same answer. So let's look at this. This one goes to infinity, and it's bigger on bottom, so I get out y equals 0. So that limit is equal to 0, so my horizontal asymptote is y equals 0. And over here, as I go to negative infinity, again I'm bigger on bottom, so that limit is 0, so my horizontal asymptote is y equals 0. Okay, looking at this one, again I have a polynomial over a polynomial. So this is a rational expression. So these two answers should be the same. So let's look at this. As I go to infinity, now I see that the degrees are the same. So I know that as I go to infinity, this is going to go to infinity. So I have negative 2 over 3. So there's my horizontal asymptote. This limit, as I go to negative infinity, I have to be careful, because a negative infinity cubed is negative times a negative, so that's actually going to be a positive 2 up there. And then down below, when I go to negative infinity, sorry about that, when I go to negative infinity, I get out a negative answer. When I cube it, a negative times 3 is a negative 3. So it's the same answer, but it kind of was a little bit differently. But I know it was a rational expression, so I should get the same answer for my horizontal asymptote. Again, over here, let me talk about this one more time. So when I went to negative infinity, a negative cubed is still a negative. So a negative times negative 2 makes it a positive 2. So it's like negative 2 times a negative. Down here, I have a negative cubed, which is a negative. So this was like a 3 times a negative. So negative times a negative up there was a positive 2, and 3 times a negative down here was a negative 3. Okay, and this one, it doesn't matter. You're bigger on top in both cases, so there are no horizontal asymptotes. However, let's go ahead and say what these limits would be. So here I can see as I go to infinity, that's going to get a positive infinity over, as I go to infinity, a positive. But it's bigger on top. So this is positive over positive is a positive infinity. Now as I go to negative infinity, so this would be a positive infinity still, because negative to the fourth is negative, or sorry, is positive. Anything to the even is positive, to the odd is negative. Over negative infinity to the third is now a negative. So this answer would be a negative infinity. Alright, let's look at this one. Now I have it bigger on top, so I know that there's no horizontal asymptote. But let's go ahead and see what these would equal for the limits. Now I have a 4 and a 2. This one was a 4 and a 3. This one is a 4 and a 2. So let's see. Infinity to the fourth is still positive, so I have a positive infinity. Over infinity squared is still a positive, so that is a positive infinity. Now let's look over here. Negative infinity to the fourth is now a positive infinity. And negative infinity squared is still a positive, so this one would be infinity. So basically it's kind of telling you your end behavior. So on this guy, the end behavior as I go out, as x goes to infinity, I know it's going to go to infinity. And over here, as x goes to negative infinity, I know that it's going to go to negative infinity. And we can talk about what happens in the middle, but my end behavior would do this. Whereas here, this one, as x went to positive infinity, it went to infinity. And as x went to negative infinity, it went to infinity. So we definitely have some different end behaviors, and that's what that is telling me as I go and take the limit to positive and negative infinity. Alright. So you pause me and summarize some things that you'd like to put from what we just discussed right there. And then when you're ready, let's keep going. Okay, look at number 5. Now we no longer have rational expressions because this one on the denominator, this function, is not a polynomial. So now that I do not have a polynomial, I know that I could get out different answers. Okay? So let's talk about this right here for a second before we decide to take the limits. So this guy right here, if I was to talk about the degree, so to speak, or the leading coefficient, so to speak, as if it would be a polynomial, I'd be looking at this right here. So the degree isn't 2, it's the square root of the x squared here, so it would actually be a degree of 1. And the leading coefficient isn't just a 3, but a square root of 3. So if I was to just to kind of think about this, if I could, which I can't, you freshman dreamers, take this x squared plus x to the 1/2, if I could kind of distribute it, I'd have the square root of 3x and some other junk. And all of those are going to be smaller degrees going on, because this was the biggest to begin with. So when I look at this, I'm really only concerned with the biggest degree down here in that function. So here I'm looking at radical 3x, and again here I'm looking at radical 3x if I was to simplify. So as I go to infinity, these have the same degree. So when they have the same degree, I'm going to take and look at the leading coefficients. So here as I go to infinity, I'm going to have a 5. And here as I go to infinity, I'm going to have a radical 3. And feel free to rationalize if you'd like. Now let's look over here. It's a little bit different. As I go to negative infinity, I still have a 5, but it's times a negative. And down here, as I go to negative infinity, I have my radical 3, but I have to look before I kind of reduce. So this would be a negative squared, which would become a positive, and a positive square rooted is still a positive. So this answer would be negative 5 over radical 3. So these are different, which we said they could be. So here my horizontal asymptotes are plus or minus 5 divided by radical 3. Okay? You guys try number 6. So again, I no longer have a polynomial, I have a fractional exponent. So let's see what happens as I go to infinity. Well, these are the same degree. So as I go to infinity, I have infinity raised to the 2/3. So that kind of be like, remember, x to the 2/3 is the same as x squared with the cube root of x. So the first thing we do is kind of square it. So infinity squared is still positive. The cube root of that is still positive, so I have a positive 5. Over infinity, well, that's the same exponent, so I'm just going to have a positive 4. So this answer is 5/4. Let's try B. So negative infinity squared now turns to a positive. Cube root is still a positive, so I have 5 with a positive. Whereas down here with the 4, it's the same kind of scenario again, so I take a negative and I square it, which is a positive. Cube root is still a positive.